Like Darius said, I'm Lars Brink. I'm the head of R&D at Keep Focus in Denmark. I'm actually also a writer for Angular and Dev, like most of your favorite Angular experts out there. But today I want to discuss how we can completely rethink our Angular projects. By the end of this talk, I will have introduced you to some experimental APIs of Ivy and why they matter to us. It's already pretty late in the afternoon though, and this is a heavy topic, so to get through this talk I actually need your help. So let's start with a show of hands. Who knows how Angular modules work? Who likes Angular modules? Really? Who would like to get rid of Angular modules? No Angular modules at all. No more people than that? Well, I'm going to leave them, because this talk is about getting rid of Angular modules using Ivy APIs. So there's one more thing, though, to keep this talk interesting. Let me tell you a little story. Let's think about Angular and the Vue engine for a second. From the outside looking in, it's this majestic framework. It looks very exclusive, kind of old school, though. But on the inside, Angular modules, they are so difficult to reason about that sometimes they make us question reality. At the same time, during all this, we've had Ivy roam the corridors for a couple of years, like some crazy man with an axe, running around an old hotel, screaming our name, waiting to chop our application into bits and pieces. What's that? Yeah, it is. It's the right slide. Yeah, we're still at the first slide. Yes, because now to move this talk along, I need all of your help. Every time the Vue engine sucks, we all yell, "Here's Ivy!" Okay? Let me try it one time. Here's Ivy! Right. And for those of you who are too young to remember, this is a reference to The Shining from 1980, old movie. The Angular team are teasing us all the time. I took note of one thing, though, in particular. At the Angular Connect conference, Igor Aminar and Alex Rigobor were discussing Angular modules. Igor said that Angular modules were actually put into the framework as a necessary evil for the sake of the compiler. I'm paraphrasing a bit here, though, but the end goal is for them to make Angular modules optional so that you can leave them out of your applications entirely. Alex said a similar thing, though, Angular modules are often confusing and they are difficult to reason about, especially to newcomers to the Angular ecosystem. And he'd also like to remove them if he could, or at least make them more simple to use. So, if only there was some rendering engine that didn't depend on Angular modules. Here's Ivy! Ivy is coming, as you know, but what will we actually get from not changing any code in our Angular projects? We will get faster rebuilds, we will get better debugging experience, slightly smaller application bundles, and it'll all be done using Ivy instruction set that's similar to the incremental DOM library by Google. All of this internal stuff, it's very nice, don't get me wrong, but where are my shiny new features? Well, this is because the top priority for the Angular team has been to maintain backwards compatibility, and they've kept that promise. So a lot of us will actually start using Ivy and not even notice. Things will just work, nothing breaks. Performance is similar, maybe a little better. Bundles are slightly smaller. So what do we do to actually get to some shiny new stuff? Well, to do that, we actually have to change our code. Because of this Ivy instruction set, we can actually tree-shake away some of the parts of Angular that we might not be using for use cases such as custom elements, micro front-ends, and applications where Angular is not in full control of the entire page. All of these use cases, they are possible with Vue engine, but they are pretty cumbersome and pretty difficult to get right. So it would be nice if we had some way to do this, because with View Engine today, we would either have really big bundles or have to share some common packages throughout the global objects. Like Max discussed earlier today, with Ivy there comes a few new experimental functions for managing state. And in this example here, we've used a function called mark30, and because this is because the zone is not part of this Ivy, vanilla Ivy application without any modules. So when the user clicks the button in this Zippy component, the method gets called, but there is no change detection trigger. So we change the local UI state and the property is expanded. But then we have to ourselves mark the component as dirty and trigger change detection. And this is done using the mark30 function, or detect changes. So today, these are kind of the use cases for Angular modules. We've already had, since version 6, tree-shakable providers. So the first item on the list we won't discuss today. It's already been covered. It's fairly simple to do that without modules. It's even easier to reason about and less error prone. Let's look at the next point here. Next use case is for linking together declarables. So in your components, you are using other components, directives, and pipes. The compiler and the Angular runtime needs to link these things together so that they actually work in your application. The problem, though, is that this is a major part of the concern of Angular modules, is linking these things together. So we are depending on the Angular modules to do this. But if only we could do better than that View engine. Here's Ivy. It's coming. And I would like to introduce you to a new concept called tree-shakable components. And what I'd like to do with tree-shakable components is that they should be entry components. Usually, the point of entry components is that they are not tree-shakable. They are always part of the bundle. But I want tree-shakable components that are entry components, but they can also be shaken out of the bundle if they are not used. They should be independent of Angular modules, so there should be no Angular modules involved at all. They should actually become the smallest compilation unit, replacing Angular modules, and they should also be the unit of code splitting we can use in Angular. So this is an example of a proposed component API proposed by the Angular team. In the component decorator here, we see the deps option, short for dependencies, declarable dependencies. So what we do here is, in this Zippy component, to use the Ivy button directive, of course we have to link it into the component and its template. So we list it in the deps array. And again, like before, we use the mark30 function to take care of state management. So one thing to notice here, there are no Angular modules, but how do we use this component in another place of the application? Let's look at this app root component instead. It actually uses the Zippy component, so it lists it in its own deps array. It also uses the capitalized pipe, so we also include that in the deps option of this component. This is exactly what we're looking for to build tree-shakable components. No modules included at all, and every time we don't use a component, it'll simply be left out of the bundle because no one's referencing it. We don't have this layer of indirection of Angular modules to link things together. This is only a proposal though, so it's nowhere to be found yet. So what can we do to actually imitate this behavior today? Let me introduce you to single component Angular modules, or SCAMs for short, Alex. SCAMs, they declare and export a single component. They are only concerned about one single component. So in their imports, they will only have imports that kind of link together these components that are used in its template. So it's only concerned about a single component and a single component template. So they are easy to verify. You only have to look through one component template to make sure that this import is actually in use. And they're also good for testing. We can place them in the same file as their component. And again, Alex, the abbreviated form is a scam. Let's look at how this actually looks in code. Like before, we have the CP component. And this is not Ivy, this is Vue engine compatible code. So we have to have modules. But we have single component Angular modules. In the bottom of this code sample, you can see that I declare the single component, the CP component. I export it, and I import the directives, pipes, and components that are used in this template. It's only the button directive though, but that's all we need. So how would we use this component and its scam in another component? In a similar way in the app component. The app component has an app module, and it imports the CP module, which is a single component Angular module for the CP component. And then again, we import a capitalized module, and this capitalized module would only declare the capitalized pipe. With this technique, we don't get actual tree-shakable components, but it's a step in the right direction, and it's something we can use today without the experimental Ivy API. So it's a safe migration path if we want to move towards tree-shakable components. Let's look at another technique, though, to depend less on Angular modules and get rid of some module references. Component render modules. These modules exclusively declare dependencies, so they don't have any import statements in their options. A weird thing, though, is that you can have duplicate declarations of the same component in multiple Angular modules, which is just wrong, but it works because this is a hack, and it only works because of some interesting timing issue. And if you want the details on that, you can ask Joost Kuhorn. This is what it looks like in code. We have the same CP component, and the interesting part is at the bottom, where we have a CP render module, and this time it declares the CP component, but also its declarable dependencies, so the button directive. Before we had the CP component declared and the button module imported. Now we declare both. Let's see how we use it in the root component. In the root component, we have the app component declared, we have the capitalized pipe compared, and again we declare the CP component, which is weird because before we also have the CP component declared in a module. Now we have it declared in two modules. This works if you use the JIT compiler. So you have to include the compiler in your bundle. An interesting thing to note here, though, is that the module class is not exported. It's not actually needed. It's only there to instruct the compiler to link the declarables together. But wouldn't it be nice if we could make this work with AOT compilation instead? Let's look at feature render modules. In feature render modules, you have one and only one module per application bundle. So that's one for the main bundle and one for every lazy loaded feature. So we get rid of a lot of these modules and the references between them, instead of still having one per component or one per declarable. So Angular will actually take care of flooding these nested arrays that we'll look at in a minute. And it'll also remove duplicates. Because if we only have one module, that means that all declarations will be declared in a single module. And we'll look at the code for that. Again, this is our CP component. And we use mark dirty for change detection. But in the bottom, you can see that we don't have a module for this component. We only have a plain old array of the component itself and its declarable dependencies. This is all it needs to work. So where do we use this array? We use it in the root component of the bundle, and this is the app component, but there would be one for every feature of the app. So, like before, we declare this app component and the capitalized pipe, but then we also include the zippy depths, which is simply an array. This array could have been nested with dependencies of other declarable dependencies. And this is where Angular will help us out, unpack all of these nested arrays and get rid of the duplicates. So using this technique, it'll allow us to actually dynamically render and bootstrap tree-shakable components. We're using the experimental Ivy APIs, though. We have to take care of change detection ourselves. But we don't have to include the compiler in the main bundle, since this is AOT compatible. So we figured out how to link declarables, and if we take a look back in View Engine land, we are still bootstrapping components using modules. There's no way around it. If only there was a renderer that didn't require Angular modules for bootstrapping. Here's Ivy. Okay. This is how we can bootstrap any component actually. As I told you before, any component, any tree-shakable component is an entry component, meaning that we can bootstrap it to any place in the DOM, and it's still tree-shakable. One thing to note though is that when we use Ivy in this way, we let go of the NgZone, which means no default change detection, so we have to use mark dirty, as you already saw, and there's no application in the initialization step anymore. Well, that takes care of that, so let's look at the last use case. We are still depending on modules to lazy load application features. Ever since Angular version 7 point something, we have had dynamic import statements in Angular apps. But still, we need Angular modules. So I wish that we could lazy load these features without Angular modules. So guess what? I forgot a slide, but here's Ivy. This is how we can lazy load components using these Ivy experimental APIs though. We can use dynamic import statements, we can unpack the component class, and we can pass it on to render component, like we see here. So it's a really simple process, not a lot of magic going on, just using the platform as it is. So that's actually it. We implemented all Angular module use cases without using any Angular modules. Pretty neat. So at this point, I'd like to thank a list of people: Alexi, Joost, Max, Wasim, and Sejang for helping me be my Ivy expert panel. I'd also like to thank Morten Kirstein for helping me review this talk. And finally, I'd like to thank everyone who's helped me with the article. This is all based on an article published on Angular in Depth. Once we get this first release version of Ivy, this is what I want to see. I want us to be able to get rid of every single Angular module in your whole application. I want us to be able to bootstrap using render component, because then we don't need modules. And then we should schedule change detection using mark dirty whenever we change local UI state. We can use the dynamic import statement to lazy load a component and pass it on to render component. And every tree-shakable component is able to render or bootstrap anywhere in our DOM. So to get started today, we can use either one of these techniques, really. The scams, they are compatible with the View engine today. So like I said, they are really safe migration path towards tree-shakable components and getting rid of Angular modules finally. They also work with Ivy Preview, both with the JIT and the AOT compiler. But if we want to take the next step, though, we have to go experimental. The first technique I showed you was how to use component render modules. That's where we have, similar to SCAMs, we have a single module per component, but instead of depending on Angular modules, they are depending directly on declarables, referencing them. This means, though, that we have duplicate declarables in multiple modules, which is kind of weird and definitely a hack. So we could also consider the feature render modules, where we have one module per application bundle, and this is compatible with Ivy Preview, both using JIT and AOT compilation. But it's even weirder. We have to propagate these nested declarable dependencies and declare all of them in a single top-level module, every bundle. But in my opinion, these techniques are the closest we can get to tree-shakable components and getting rid of Angular modules, and we can start using them today. Rob Wormel was actually asking us to get feedback on this component proposal with the depth property, but it's nowhere to be found in the code, so we have to run experiments ourselves to be able to get him the feedback he needs, whether to see is this something that makes sense in our applications, and which nice features can we get out of it. The first release version of Ivy will probably be in Angular version 9. The experimental change detection and rendering API will probably still be experimental. The composed component API will probably not be available, and maybe not ever, but that's where we come into the picture, like I said. So to get all of the details, you can read my article on Angular in depth. And now I want to urge all of you to go experiment with this and send a lot of tweets to Rob Wormel saying, this is great, let's get rid of modules. Interesting enough, making components this small unit of compilation and a small unit for code splitting is completely in line with what Misko Hevery has as a vision for the Angular framework for the future. So let's take a step in that direction and make it happen and get rid of Angular modules. Thank you, everyone.